Section 6 of National Geographic Magazine, Volume 1, Number 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Rivers and Valleys of Pennsylvania, Part 4b, by William Morris Davis. 31. Reversal of larger rivers to southeast courses. Our large rivers at present flow to the southeast, not to the northwest. It is difficult to find any precise date for this reversal of flow from the initial hypothetical direction, but it may be suggested that it occurred about the time of the Triassic depression of the Newark belt. We have been persuaded that time elapsed between the Permian folding and the Newark deposition, even under the most liberal allowance for pre-Permian erosion in the Newark belt. Hence, when the depression began, the rivers must have had but moderate northwestward declivity. The depression and submergence of the broad Newark belt may at this time have broken the continuity of the streams that once flowed across it. The headwater streams from the ancient Archean country maintained their courses to the depression. The lower portions of the rivers may also have gone on as before, but the middle courses were perhaps turned from the central part of the state back of the Newark belt. No change of attitude gives so fitting a cause of the southeastward flow of our rivers as this. The only test that I have been able to devise for the suggestion is one that is derived from the relation that exists between the location of the Newark belt along the Atlantic slope and the course of the neighboring transverse rivers. In Pennsylvania, where the belt reaches somewhat beyond the northwestern margin of the crystalline rocks in South Mountain, the streams are reversed, as above stated. But in the Carolinas, where the Newark belt lies far to the east of the boundary between the Cambrian and crystalline rocks, the Tennessee streams persevere in what we suppose to have been their original direction of flow. This may be interpreted as meaning that in the latter region the Newark depression was not felt distinctly enough, if at all, within the Allegheny belt to reverse the flow of the streams, while in the former region it was nearer to these streams and determined a change in their courses. The original Anthracite River ran to the northwest, but its middle course was afterwards turned to the southeast. I am free to allow that this has the appearance of heaping hypothesis on hypothesis, but in no other way does the analysis of the history of our streams seem possible, and the success of the experiment can be judged only after making it. At the same time, I am constrained to admit that this is, to my own view, the least satisfactory of the suggestions here presented. It may be correct, but there seems to be no sufficient exclusion of the other possibilities. For example, it must not be overlooked that, if the Anthracite River ran southeast during Newark deposition, the formation of the Newark northwestward monocline by the Jurassic tilting would have had a tendency to turn the river back again to its northwest flow. But as the drainage of the region is still southeastward, I am tempted to think that the Jurassic tilting was not here strong enough to reverse the flow of so strong and mature a river as the Anthracite had by that time come to be, and that the elevation that accompanied the tilting was not so powerful in reversing the river to a northwest course as the previous depression of the Newark basin had been in turning it to the southeast. If the Anthracite did continue to flow to the southeast, it may be added that the downcutting of its upper branches was greatly retarded by the decrease of slope in its lower course when the monocline was formed. The only other method of reversing the original northwestward flow of the streams that I have imagined is by capture of their headwaters by Atlantic rivers. This seems to me less effective than the method just considered, but they are not mutually exclusive, and the actual result may be the sum of the two processes. The outline of the idea is as follows. The long-continued supply of sedimentary material from the Archean land on the southeast implies that it was as continually elevated. But there came a time when there was no record of further supply of material, and when we may therefore suppose the elevation was no longer maintained. From that time onward, the Archean range must have dwindled away. What with the encroachment of the Atlantic on its eastern shore and the general action of denuding forces on its surface. The Newark Depression was an effective aid to the same end, as has been stated above, and for a moderate distance westward of the depressed belt, the former direction of the streams must certainly have been reversed. But the question remains whether this reversal extended as far as the Wyoming Basin, and whether the subsequent formation of the Newark monocline did not undo the effect of the Newark Depression. It is manifest that, as far as our limited knowledge goes, it is impossible to estimate these matters quantitatively, and hence the importance of looking for additional processes that may supplement the effect of the Newark Depression and counteract the effect of the Newark uplift in changing the course of the rivers. Let it be supposed for the moment that, at the end of the Jurassic uplift by which the Newark monocline was formed, the divide between the Ohio and the Atlantic drainage lay about the middle of the Newark belt. There was a long, gentle descent westward from this watershed, and a shorter and hence steeper descent eastward. Under such conditions, the divide must have been pushed westward, and as long as the rocks were so exposed as to open areas of weak sediments on which capture by the Atlantic streams could go on with relative rapidity, the westward migration of the divide would be important. For this reason, it might be carried from the Newark belt as far as the present Allegheny front, beyond which further pushing would be slow, on account of the broad stretch of country there covered by hard horizontal beds. The end of this is that, under any of the circumstances here detailed, there would be early in the Jurassic-Cretaceous cycle a distinct tendency to a westward migration of the Atlantic-Ohio divide. It is the consequences of this that have now to be examined. 32. Capture of the Anthracite headwaters by the growing Susquehanna. Throughout the Perm-Triassic period of denudation, a great work was done in wearing down the original Alleghanies. Anticlines of hard sandstone were breached, and broad lowlands were opened on the softer rocks beneath. Little semblance of the early constructional topography remained when the period of Newark Depression was brought to a close. And all the while the headwater streams of the region were gnawing at the divides, seeking to develop the most perfect arrangement of waterways. Several adjustments have taken place, and the larger streams have been reversed in the direction of their flow. But a more serious problem is found in the disappearance of the original master stream, the great Anthracite River, which must have at first led the water away from all the lateral synclinal streams. Being a large river, it could not have been easily diverted from its course, unless it was greatly retarded in cutting down its channel by the presence of many beds of hard rocks on its way. The following considerations may perhaps throw some light on this obscure point. It may be assumed that the whole group of mountains formed by the Permian deformation had been reduced to a moderate relief when the Newark deposition was stopped by the Jurassic elevation. The harder ribs of rock doubtless remained as ridges projecting above the intervening lowlands, but the strength of relief that had been given by the constructional forces had been lost. The general distribution of residual elevations then remaining unsubdued is indicated in Figure 25, in which the crystalline, the Medina, and the two carboniferous sandstone ridges are denoted by appropriate symbols. In restoring this phase of the surface form, when the country stood lower than now, I have reduced the anticlines from their present outlines and increased the synclines, the change of area being made greatest where the dips are least, and hence most apparent at the ends of the plunging anticlines and synclines. Some of the Medina anticlines of Perry and Juniata counties are not indicated because they were not then uncovered. The country between the residual ridges of Jurassic time was chiefly Cambrian limestone and Siluro-Devonian shales and soft sandstones. The moderate ridges developed on the Oriskany and Chemung sandstones are not represented. The drainage at this stage retained the original courses of the streams, except for the adjustments that have been described. But the great Anthracite River is drawn as if it had been controlled by the Newark Depression and reversed in the direction of its flow, so that its former upper course on the Cambrian rocks was replaced by a superimposed Newark lower course. Figure 26 therefore represents the streams for the most part still flowing near their synclinal axes, although departing from them where they have to enter a synclinal cove mountain ridge. The headwaters of the Juniata avoid the mass of hard sandstones discovered in the bottom of Old Broadtop Lake, and flow around them to the north, and then by a cross-country course to the Wiconisco synclinal, as already described in detail. Several streams come from the northeast, entering the anthracite district after the fashion generalized in Figure 13. 3 of the many streams that were developed on the Great Kittatinny Slope are located with their direction of flow reversed. These are marked SQ, L, and D, and are intended to represent the ancestors of the existing Susquehanna, Lehigh, and Delaware. We have now to examine the opportunities offered to these small streams to increase their drainage areas. The Jurassic elevation, by which the Newark deposition was stopped, restored to activity all the streams that had been in the previous cycle sought, and found a course close to base level. They now all set to work again, deepening their channels. But in this restoration of lost activity, with reference to a new base level, there came the best possible chance for numerous rearrangements of drainage areas by mutual adjustment into which we must inquire. I have already illustrated what seems to me to be the type of the conditions involved at this time in Figures 19 and 20. The master stream A, traversing the synclines, corresponds to the reversed Anthracite River. The lowlands at the top are those that have been opened out on the Siluro-Devonian beds of the present Susquehanna middle course between the Pocono and the Medina ridges. The small stream B, that is gaining drainage area in these lowlands, corresponds to the embryo of the present Susquehanna, SQ, Figure 25. This having been itself once a branch on the south side of the Swatara synclinal stream, Figure 21, from which it was first turned by the change of slope accompanying the Newark depression. But it is located a little farther west than the actual Susquehanna, so as to avoid the 2 synclinal cove mountains of Pocono sandstone that the Susquehanna now traverses, for reasons to be stated below in section 35. This stream had to cross only one bed of hard rock, the outer wall of Medina sandstone, between the broad inner lowlands of the relatively weak Siluro-Devonian rocks and the great valley lowlands on the still weaker Cambrian limestones. Step by step it must have pushed its headwater divide northward, and from time to time it would have thus captured a subsequent stream that crossed the lowlands eastward and entered a carboniferous syncline by one of the lateral gaps already described. With every such capture, the power of the growing stream to capture others was increased. Figure 19 represents a stage after the streams in the Swatara and Wiconisco synclines. The latter then, having gained the Juniata, had been turned aside on their way to the Carboniferous basins. On the other hand, the Anthracite River, rising somewhere on the plains north of the Wyoming syncline, and pursuing an irregular course from one coal basin to another, found an extremely difficult task in cutting down its channel across the numerous hard beds of the Carboniferous sandstones, so often repeated in the rolling folds of the coal fields. It is also important to remember that an aid to the other conditions concerned in the diversion of the upper anthracite is found in the decrease of slope that its lower course suffered in crossing the coal fields, if that area took any part in the deformation that produced the Newark monocline. Whichever theory proved true in regard to the origin of the southeastward flow of the rivers, for loss of slope in the middle course, where the river had to cross many reefs of hard sandstone, would have been very effective in lengthening the time allowed for the diversion of the headwaters. The question is, therefore, whether the retardation of downcutting here experienced by the anthracite was sufficient to allow the capture of its headwaters by the Susquehanna. There can be little doubt as to the correct quality of the process, but whether it was quantitatively sufficient is another matter. In the absence of any means of testing its sufficiency, may the result not be taken as a test? Is not the correspondence between deduction and fact close enough to prove the correctness of the deduction? 33. Present outward drainage of the anthracite basins. The Lehigh, like the Susquehanna, made an attempt to capture the headwaters of adjacent streams, but failed to acquire much territory from the anthracite because the Carboniferous sandstones spread out between the two in the broad plateau of hard rocks, across which the divide made little movement. The plateau area that its upper branches drain is, I think, the Conquest, a later cycle of growth. The Delaware had little success, except as against certain eastern synclinal branches of the anthracite, for the same reason. The ancestor of the Swatara of today made little progress in extending its headwaters because its point of attack was against the repeated Carboniferous sandstones in the Swatara synclinal. One early stream alone found a favorable opportunity for conquest, and thus grew to be the master river, the Susquehanna of today. The head of the anthracite was carried away by this captor, and its beheaded lower portion remains in our Schuylkill. The anthracite coal basins, formerly drained by the single master stream, have since been apportioned to the surrounding rivers. As the Siluro-Devonian lowlands were opened around the coal basins, especially on the north and west, the streams that formerly flowed into the basins were gradually inverted and flowed out of them, as they still do. The extent of the inversion seems to be, in a general way, proportionate to its opportunity. The most considerable conquests were made in the upper basins, where the Catawissa and Nescopec streams of today drain many square miles of wide valleys opened on the Mauch Chunk Red Shale between the Pocono and Pottsville sandstone ridges. The ancient middle waters of the anthracite here being inverted to the Susquehanna tributaries, because the northern coal basins were degraded very slowly after the upper anthracite had been diverted. The Schuylkill, as the modern representative of the anthracite, retains only certain streams south of a medial divide between Nescopec and Blue Mountains. The only considerable part of the old anthracite river that still retains a course along the axis of the synclinal trough seems to be that part which follows the Wyoming Basin. None of the many other coal basins are now occupied by the large stream that originally followed them. The reason for this is manifestly to be found in the great depth of the Wyoming Basin, whereby the axial portion of its hard sandstone are even now below base level, and hence have never yet acted to throw the river from its axial course. Indeed, during the early cycles of denudation, this basin must have been changed from a deep lake to a lacustrine plain by the accumulation in it of waste from the surrounding highlands, and for a time the streams that entered it may have flowed in meandering courses across the ancient alluvial surface. The lacustrine and alluvial condition may have been temporarily revived at the time of the Jurassic elevation. It is perhaps as an inheritance from a course thus locally superimposed that we may come to regard the deflection of the river at Nanticoke from the axis of the syncline to a narrow shale valley on its northern side, before turning south again and leaving the basin altogether. But like certain other suggestions, this can only be regarded as an open hypothesis, to be tested by some better method of river analysis than we now possess. Like several of the other explanations here offered, it is presented more as a possibility to be discussed than as a conclusion to be accepted. I believe that it was during the earlier part of the great Jura-Cretaceous cycle of denudation that the Susquehanna thus became the master stream of the central district of the state. For the rest of the cycle, it was occupied in carrying off the waste and reducing the surface to a well-finished base-level lowland that characterized the end of Cretaceous time. From an active youth of conquest, the Susquehanna advanced into an old age of established boundaries, and in later times its area of drainage does not seem to have been greatly altered from that so long ago defined, except perhaps in the districts drained by the west and north branch headwaters. 34. Homologies of the Susquehanna and Juanita. Looking at the change from the anthracite to the Susquehanna in a broad way, one may perceive that it is an effect of the same order as the peripheral diversion of the broad-top drainage illustrated in figures 22, 23, and 24. Another example of a similar change is seen in the lateral diversion of the Juniata above Lewistown, and its rectilinear continuation in Auquick Creek, from their original axial location when they formed the initial broadtop outlet. They have departed from the axis of their syncline to the softer beds on its southern side. FE of figure 17 has been diverted to FD of figure 18. All of these examples are truly only special cases of the one already described, in which the Juanita left its original syncline for others to the south. The general case may be stated in a few words. A stream flowing along a syncline of hard beds, carboniferous sandstones, develops side streams which breach the adjacent anticlines and open lowlands in the underlying softer beds, Devonian and Silurian. On these lowlands, the headwaters of side streams from other synclines are encountered, and a contest ensues as to possession of the drainage territory. The divides are pushed away from these headwaters, whose lower courses leads them over the fewest hard barriers. This conquest goes on until the upper course of the initial mainstream is diverted to a new and easier path than the one it chose in its youth, in obedience to the first deformation of the region. Thus the Juanita now avoids the center and once deepest parts of the old Broadtop Lake, because in the general progress of erosion, lowlands on soft Devonian beds were opened all around the edge of the great mass of sandstones that held the lake. The original drainage across the lake, from its western slopes to its outlet just south of the Jacks Mountain anticline, has now taken an easier path along the Devonian beds to the west of the old lake basin, and is seen in the Little Juanita, flowing along the outer side of Terrace Mountain and rounding the northern synclinal point where Terrace Mountain joins Sidling Hill. It then crosses Jacks Mountain at a point where the hard Medina sandstones of the mountain were still buried at the time of the choice of this channel. In the same way, the drainage of the subordinate basin, through which the main lake discharged eastward, is now not along the axis of the Juanita-Catawissa syncline, but on the softer beds along one side of it, and along the southern side because the easier escape that was provided for it lay on that side, namely via the Tuscaroys and Wiconisco synclines, as already described. The much broader change from the Anthracite to the Susquehanna was only another form of the same process. Taking a transverse view of the whole system of central folds, it is perceived that their axes descend into the Anthracite district from the east and rise westward therefrom. It is as if the whole region had received a slight transverse folding, and the transverse axis of depression thus formed defined the initial course of the first master stream. But this master stream deserted its original course on the transverse axis of depression, because a lateral course across lowlands on softer beds was opened by its side streams. And in the contest of these lowlands with an external stream, the Susquehanna, the upper portion of the Anthracite, was diverted from the hard rocks that had appeared on the transverse axis. The distance of diversion from the axial to the lateral course in this case was great, because of the gentle quality of the transverse folding, or, better said, because of the gentle dips of the axes of the longitudinal folds. This appearance of systematic rearrangement in the several river courses, where none was expected, is to my mind a strong argument in favor of the original consequent location of the rivers and their later mutual adjustment. It may perhaps be conceived that antecedent streams might imitate one another, roughly in the attitude that they prophetically chose with regard to folds subsequently formed, but no reason has been suggested for the imitation being carried to so remarkable and definite a degree as that here outlined. 35. Superimposition of the Susquehanna on two synclinal ridges. There is, however, one apparently venturesome postulate that may have been already noted as such by the reader. Unless it can be reasonably accounted for and shown to be a natural result of the long sequence of changes here considered, it will seriously militate against the validity of the whole argument. The present course of the middle Susquehanna leads it through the apical curves of the two Pocono synclinal ridges, which were disregarded in the statement given above. It was then assumed that the embryonic Susquehanna gained possession of the Siluro-Devonian lowland drainage by gnawing out a course to the west of these synclinal points, for it is not to be thought of that any conquest of the headwaters of the Anthracite River could have been made by the Susquehanna, if it had had to gnaw out the existing four traverses of the Pocono sandstones before securing the drainage of the lowlands above them. The backward progress of the Susquehanna could not in that case have been nearly fast enough to reach the anthracite before the latter had sunk its channel to a safe depth. It is therefore important to justify the assumption as to the more westerly location of the embryonic Susquehanna, and afterwards to explain how it should have since then been transferred to its present course. A shortcut through all this roundabout method is open to those who adopt in the beginning the theory that the Susquehanna was an antecedent river. But, as I have said at the outset of this inquiry, it seems to me that such a method is not freer from assumption, even though shorter than the one here adopted. And it has the demerit of not considering all the curious details that follow the examination of consequent and adjusted courses. The sufficient reason for the assumption that the embryonic Susquehanna lay farther west than the present one in the neighborhood of the Pocono synclinals is simply that, in the absence of any antecedent stream, it must have lain there. The whole explanation of the development of the Siluro-Devonian lowlands between the Pocono and Medina ridges depends simply on their being weathered out where the rocks are weak enough to waste faster than the enclosing harder ridges through which the stream escapes. In this process, the streams exercise no control whatever over the direction in which their headwaters shall grow. They leave this entirely to the structure of the district that they drain. It thus appears that, under the postulate as to the initial location of the Susquehanna, as one of the many streams descending the great slope of the Kittatinny or Cumberland highland into the Swatay syncline, its course being reversed from northward to southward by the Newark depression, we are required to suppose that its headwater, the northward growth at the time of the Jurassic elevation, must have been on the Siluro-Devonian beds, so as to avoid the harder rocks on either side. Many streams competed for the distinction of becoming the master, and that one gains its ambition whose initial location gave it the best subsequent opportunity. It remains then to consider the means by which the course of the conquering Susquehanna may have been subsequently changed from the lowlands onto the two Pocono synclines that it now traverses. Some departure from its early location may have been due to eastward plantation in its advanced stage, when it had large volume and gentle slope, and was therefore swinging and cutting laterally in its lower course. This may have had a share in the result, but there is another process that seems to me to be more effective. In the latter part of the Jura-Cretaceous cycle, the whole country hereabouts suffered moderate depression, by which the Atlantic transgressed many miles inland from its former shoreline, across the lowlands of erosion that had been developed on the littoral belt. Such a depression must have had a distinct effect on the lower courses of the larger rivers, which, having already cut their channels down close to base level and opened their valleys wide on the softer rocks, were then estuaried, or at least so far checked as to build wide floodplains over their lower stretches. Indeed, the floodplains may have been begun at an earlier date and have been confirmed and extended in the later time of depression. Is it possible that in the latest stage of this process, the almost base-leveled remnants of Blue Mountain and the Pocono ridges could have been buried under the floodplain in the neighborhood of the river? If this is to be admitted, it is then natural for the river to depart from the line of its buried channel and cross the buried ridges on which it might settle down as a superimposed river in the next cycle of elevation. It is difficult to decide such general questions as these, and it may be difficult for the reader to gain much confidence in the efficacy of the processes suggested, but there are certain features in the side streams of the Susquehanna that lend some color of probability to the explanation as offered. Admit for the moment that the aged Susquehanna, in the later parts of the Jurassic Cretaceous cycle, did change its channel somewhat by cutting to one side, or by planation as it is called. Admit also that in the natural progress of its growth it had built a broad floodplain over the Siluro-Devonian lowlands, and that the depth of this deposit was increased by the formation of an estuarine delta upon it when the country sank at the time of the mid-Cretaceous transgression of the sea. It is manifest that one of the consequences of all this might be the peculiar course of the river that it is to be explained, namely, its superimposition on the two Pocono-synclinal ridges in the next cycle of its history. After the tertiary elevation had been given its opportunity to rediscover them, it remains to inquire what other consequences should follow from the same conditions, and from these to devise tests of the hypothesis. End of section 6.